All right, so chapter 7 is all about ionic and metallic bonding. And you've kind of found some definitions already in preparation for your lab. And we have also talked about ions previously. So the first part of chapter 7 is just kind of refreshing your memory on ions. And so remember that the outermost electrons are called the valence electrons, and that those valence electrons are equal to the family number on the periodic table. Now, we have referred to these as 1, 2, 3, 4, 5, 6, 7, 8. We wrote that on one of your periodic tables. Some of you had trouble with that on the test. Yes, there are different ways of counting. That's why I said that when you are counting for valence electrons, you skip the transition elements. Okay, so our example group 5A has 5 valence electrons. Okay, helium, even though it's in family number 8, only has 2 valence electrons. So that's kind of an exception. So the octet rule states that atoms will gain or lose electrons, and the goal in this is that they reach the electron configuration of the noble gases. Noble gases are non-reactive, so if they can get to this electron configuration, then reaction will stop. They won't react any further. So the electron configuration for the noble gases is generally that. And what happens is the octet rule, again, and we did talk about this before, remember octet is 8. Okay, the goal is for metals to lose electrons to get 8, and they have a complete octet in the next lowest energy level. So if you can imagine, you have an atom, all right, and let's say you have, 1 out here. Yes, you leave that 1, then this is basically empty all around out here. So then what will happen is that means that there'll be octet on the previous level. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, atoms of nonmetals, and we've talked about this, tend to gain electrons. So nonmetals are over here, metals are over here. These generally form positive ions. These generally form negative ions. And you have read about this, so this should be very familiar. Okay, so first was formation of cations. And again, cations are positively charged ions. Okay, so remember the little t is the plus. When naming a cation, and this is important because you will use this later when we are naming compounds. When naming a cation, you use the element name. Okay, so if it is a plus, it is then just referred to that element. So for example, sodium forms an ion by losing 1 electron, and so therefore it is called the sodium ion. Now, ions have different properties than the atom they were derived from. For example, if you just take sodium and you put it in H2O, it is explosive. Whereas if you take Na+, it is unreactive. Okay, so the reason why is because we have formed, by losing that electron, the electron configuration of a noble gas. So if we look at writing the electron configuration, and on the periodic table, we have sodium is right here, and neon is right here. All right, so if we write the electron configuration for sodium plus, now Sodium plus means that instead of, it is atomic number, oops, did I do this? Oops, I did it one lower. Okay, ignore that. There, I used the eraser. Instead of doing the full electron configuration, 1s2, 2s2, 2p6, what will happen is we are going to lose one electron. So originally, sodium is atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? And so we would have to account for 11 electrons. However, this is an ion. Sodium has lost one electron. Therefore, instead of 11, we are going to account for 10. And of course, I wrote that wrong. So let me fix that. Okay, so 11 minus 1 equals 10. And if you count up the electrons that are here, 6 plus 2 is 8, plus 2 is 10. That is the electron configuration for the sodium ion. Now, regular neon is right here. So neon has the electron configuration of 1s2, 2s2, 2p6. Okay, neon is atomic number 10, and therefore there only needed to be 10 electrons accounted for, 6, 7, 8, 9, 10. So you can see that these two are identical in their electron configurations, and that is why sodium ions are unreactive. Now, let's talk about something different. We did not talk about this before, but I know that you did think of it when you were in middle school. I want to draw electron dot structures with you, and I know that you have done this previously because some of you actually talked about it. So if we look at the periodic table, we have sodium as the element that is in family number 1. Okay, so family 1. And normally what you would do for an electron dot structure is you would simply put one dot around the symbol in order to show that it has one valence electrons, because remember the family is related to how many valence electrons there are. So calcium is in family 2, and therefore calcium has this electron configuration, 2 valence electrons. Now the question, or excuse me, the electron dot structure, the question asks us to draw Ca2 plus and Na plus. So we have to lose that electron, and when we do, it becomes a negative or a positive charge. And calcium, when it loses its electrons, because of course it's easier to lose 2 than get 6, calcium will have 2 plus. Okay, so you don't have any electrons around those atoms. Now, formation of anions. Anions is a group of atoms or an atom with a negative charge. The way that you name anions, though, is not the same. In an anion, it typically, the name will end in IDE. Okay, so "ide" is added at the end. For example, the chlorine will become the chloride ion. Oxygen will become oxide. And because nonmetals have relatively full valence shells, atoms will attain the noble gas by gaining electrons. The noble gas configuration is how they will get that. So the electron dot structure for chlorine. Let's go up here to make more space. Chlorine, as you can see here, is in family number 7. So chlorine itself would have an electron configuration of 1, 2, 3, 4, 5, 6, 7. But when the chloride ion will look like this. It will have all 8. 1, 2, 3, 4, 5, 6, 7, 8. And it will have a charge of 1 minus because it has gained 1 electron. Now for sulfur, that is in family 6. So sulfur, 1, 2, 3, 4, 5, 6. And then when it forms an anion, it gains 2 electrons, so it would look like this, sulfur. And it would have 1, 2, 3, 4, 5, 6, 7, 8. And because it's gained 2 electrons, it will have a charge of -2. I write 2 minus. Some people write -2. I'm okay either way. So then ionic bonds and ionic compounds. The formation of ionic compounds is when cations and anions come together. And ionic compounds are metals and nonmetals. And the way that we write that is metals to nonmetals. And that's something you have just got to remember. Remember, ionic bonds form between metals and nonmetals. So because of that, even though they're composed of ions, because you have a positive ion and a negative ion, that means that the overall charge is neutral in an ionic compound. So anions and cations have opposite charges and will attract one another by what we call electrostatic forces. And what those do is they hold the ions together, and that is what is called an ionic bond. You've read about it, you know what you have been studying, and so you have seen that definition. One thing that happens is that often we will say a transfer of electrons, and I say that myself, but what you have to remember too is that yes, there is a gain and a loss of electrons, and when you have a ionic bond, they're not really connected. They're just by force coming together, all right? So let me show you an example. Okay, so we have sodium, and sodium has a valence electron of 1 because it is in family 1. And we have chlorine that has a valence electron of 7 because it is in family 7. So what will happen is this electron from sodium will go over here and fill that spot where chlorine is, and the result is that you will have a sodium that has a 1 plus charge, and you will have a chloride ion, and that chloride ion will have 8 electrons, and I am going to draw this one black to signify the sodium electron that originally was present, even though on the previous one I pointed up here. So then the charge will be 1 minus. Okay, this is sodium chloride. Okay, it is made from a sodium ion and a chloride ion. So formula units. basically, chemical formulas show the number of and kinds of atoms. And what we will be working on this in the chapters 7 through 9. The formula unit is the lowest whole number ratio. So if you look at the formula unit for sodium chloride, it's NaCl. What is the formula unit for magnesium chloride? MgCl2. Okay, those are the lowest. And let's look at writing formulas for some ionic compounds using the electron dot method. So if we start here, we have potassium, and I'm going to do this over here. Potassium is in family 1. It has 1 valence electron, and oxygen is in family number 6. So it has 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay? Now, remember, the goal is to have 8. So what's going to happen is that 1 electron from potassium is going to move over here to this oxygen. So then oxygen will have 7. But that's still just 7. So what's going to happen, and this is the key to all of this for this whole section here, there will be another potassium. And that other potassium will contribute a second electron. And so what you end up with in the end is 2 potassium ions. Okay, notice that I put the bracket around the 2 of them, and I put the charge inside the bracket, so you have 2 positive charge ions, and we also have an oxygen, and that oxygen has 8 valence electrons, and its charge is 2-. So then, if we look at that, the whole point of this is predicting the formulas. So if we have 2 potassiums and 1 oxygen, the formula will be K2O. And you always have the cations first and the anions second, and that's why I have potassium on the left and oxygen on the right. Let's do one more, magnesium and nitrogen. Okay, so magnesium is in family number 2, and so it is 2, or excuse me, whoa, what's going on? I'm going to make it a little smaller. Magnesium, and feel free to pause right now and try it on your own. Magnesium is in family 2, so it has 2 valence electrons. Nitrogen is in family 5, so it has 1, 2, 3, 4, 5 valence electrons. Notice I put 1 per side when I'm doing the dots, and then only add a second one, kind of like with the electron configurations. So anyway, so here we have our magnesium, and 1 and 2, those 2 will leave, but there's still an empty spot. We still need another electron. So what's going to happen is you will have to add another magnesium. And that magnesium has 2 valence electrons, and 1 of them will go to that nitrogen. But there's still another valence electron. So what are you going to do? Yep, that's right. You are going to add another nitrogen. So 1, 2, 3, 4, 5. And what will happen is this electron from this magnesium will come over here to this nitrogen. But you still have 2 open spots in that nitrogen. Therefore, what you're going to do is add another magnesium. I'm kind of running out of space, but I think I can do it. So another magnesium with 2 valence electrons, and those will go over. And now every one of these has lost or gained the amount they need for octet. So then what you end up with is you have 3 3 Mg 2 plus, and you have 2 N, and you've got to show that you have your valence electrons. And since each of them gained 3, each of those nitrogen is 3 minus. Okay, and that goes within the bracket. Okay, so sorry, that's kind of, I'm running out of room there, but you can see. So anyway, so you have 3 magnesium and you have 2 nitrogen, and magnesium is positive, it's the cation, so it will go first when we're writing the formula like we did up here, and so it'll be Mg3, and nitrogen is second, and it is the anion N2, Mg3N2, and that is the formula. So the last thing, and this is kind of what you are looking at in your lab, so we don't really want to elaborate too much, but these are some of the things that you can use to test to determine if something is an ionic compound. So crystalline solids, so you'll be able to look at them under the microscope or with a magnifying glass. High melting points, you can heat the compounds to determine if they melt at a high temperature, and you can see if first they dissolve in water, and second, once they are dissolved, do they carry an electron current. So that is very important, that little section right there, in preparation for the lab, because remember how I said there are 5 tests that I want you to do, even though you can find way more. There's 1, 2, 3, 4 of them right there. Okay. So then again, ionic compounds, their properties are independent, of the elements that make up the compound. So if you have sodium by itself, it reacts vigorously with water. If you have chlorine by itself, it's a poisonous gas. But together they make salt, and you eat salt within your food. Sometimes people add it, and you are completely fine eating it.